Welcome back. Today we're going to look at nth root, radicals, and rational exponents. So when we have a radical expression, we'll have an index for that radical. So if it's square root, we actually don't write the 2, we just understand that's a 2. But here we have a fifth root, and we could rewrite the fifth root of 32 raised to the fourth as 32 raised to the fourth raised to the 1/5, because that fifth root becomes a fraction. And we could simplify that with the properties of exponents. So multiplying the 4 and the 1/5 to make 32 raised to the 4/5. Now we could change something that's in exponential form back into radical form. So if we have 729 raised to the 5/6, well, that's going to be 729 raised to the 1/6 raised to the 5th. And that 6 becomes the sixth root of 729, and everything's raised to the 5th. So in general, looking at the rule, the nth root of c to the m can be rewritten as c to the m raised to the 1 over n, and we can multiply those powers, so m over n, as the exponent. And we could change it back into radical form by separating those exponents and finding the nth root. Okay, we're going to use that idea when we solve equations. So when we solve, we're going to have something like x cubed equals 1,728. And to get rid of the cube, we're going to raise it to the 1/3. And this is another way. So x cubed equals 1,728. Remember, the other way, using radicals, was to say, I'm going to take the cube root versus the square root. And 12 times 12 times 12 gives us 1,728. So the answer is x equals 12. And make sure you have your calculator handy for this. Okay, so let's go do some practice problems. So when we look at 125 and we want to determine what are the real cube roots of 125, well, we could say x cubed minus 125 equals 0, because we're saying what's x going to be if it's cubed to equal 125? Right? So we could subtract that and factor it. But intuitively, you could probably figure out that really easily, because 5 cubed equal 125. And so 5 is going to be the only real cube root of 125. Now when we consider the fourth root of 16, well, remember we could write that as x equals the fourth root of 16. We're seeing what number multiplied by itself 4 times would give us 16. And we know that 2 raised to the 4th equals 16. And we also know negative 2 raised to the 4th equals 16. So we're going to get 2 answers there because it's a fourth root. And remember, if we factored this, this binomial here would give us imaginary roots. So there's only 2 real fourth roots. So if we have 16 raised to the 1/4, we could rewrite that as 2 to the 4th, because remember we said 2 times 2 times 2 times 2 gives us 16, raised to the 1/4. So the fourth root of 16 would be 2. So just remember, when we're simplifying it, we're getting one answer out. So x to the 1n equals nth root of x. Now let's look at 27 raised to the 2/3. So we can rewrite this as 27 raised to the 1/3 squared, and we know the cube root of 27 is 3. So 3 squared equals 9. All right, let's evaluate these expressions. So we're going to rewrite them and simplify them. So we have 32 to the 3/5. Let's separate that into 32 raised to the 1/5, then cubed. So remember, 2 to the 5th equals 32. And this will be simplified to 2 cubed, which is 8. For 27 raised to the negative 2/3, we can separate that exponent again. The cube root again of 27 was 3, so 3 raised to the negative 2 is 1 over 9. Now 50 raised to the 3/4, well, even if I rewrote it, 50 cubed and the fourth root of that. Well, there's no number that's going to come out evenly. So you will definitely need to use a calculator for that problem. And when you use a calculator, you'll get approximately 18.8. Now, a good application of roots is the Fujita scale of tornadoes. So if we have a tornado with an estimated wind speed of 100 miles per hour, we can determine the Fujita scale rating with this formula. We're going to substitute W with 100 and then simplify it. So we have 100 here divided by 14.1, which gives us 7.09 about, because we're rounding here, but we're going to raise that to the 2/3. So rewrote this as 2 over 3. So 7.09 raised to the 2/3 is 3.69. And when we subtract 2, we get 1.69. So the Fujita scale for a tornado with wind speeds of 100 miles per hour will be 1.69. Okay, now that we have a better idea of radicals and rational exponents, let's simplify the expressions. So here we have the 5th root of 32 times m to the 15th. Now we could rewrite this as an exponent, right? So we could say that's 32 m to the 15th raised to the 1/5. We know that 32, well, the 5th root is going to be 2. That's going to come out. We have 2 to the 5th. And then with the m, we're going to have 15 over 5, or 15 divided by 5, and that's 3. So our final answer will be 2m cubed. Now let's look at b. This is the 4th root of x to the 20th times y to the 8th. So we can rewrite this as x to the 20th y to the 8th raised to the 1/4. Now remember, this is a 4th root, so only positive numbers can come out. So that's why we're going to use the absolute value symbol here. So 20 times 1/4 will be 5, so we'll have x to the 5th. 8 times 1/4, well, that's just 2. So our final answer will be absolute value of that, because we have a 4th root. If we squared any of those numbers, it'll be positive, but we kept the absolute value for the x, because raised to the 5th, you'll still have an odd number. Okay, so solving, whenever we solve, again, we're going to make sure we try to get rid of that radical, or if it's an exponent, raise it to its reciprocal. So if it have x to the n, we're going to raise it both sides to the 1 over n. Okay, so let's solve. So here we have 2x to the 5th equals 64. The first step we want to do is make sure that we get x to the 5th by itself. So we're going to have to divide both sides by 2. So we get x to the 5th equals 32. And to get rid of the 5th, we know we have to raise this to the 1/5. And 32 raised to the 1/5 is going to be 2, because 2 to the 5th equals 32. So make sure we always isolate the variables before raising that power. All right, for the last example, we're going to look at a word problem. In this example, we have a cube-shaped container, and it has an edge length 2 centimeters longer than the edge length of a second cube. So you can see here's the big cube, and again, this width here is going to be 2 centimeters longer. The volume of the larger cube is 729 centimeters cubed. You can see right there. When the larger cube empties into the smaller cube, how much water will spill? So how much extra water will there be? So we have to find the volume of each of these cubes and then subtract the difference. So if we know that the volume of the cube is s cubed, well, we could set x plus 2, because that's going to be the side length of this larger cube, right? So if this is the larger cube, each of these dimensions will be x plus 2. So we'll have to have x plus 2 cubed to get the volume of the larger cube. To solve that, we'll have to raise both sides to the 1/3. And so 729 raised to the 1/3, well, that's actually 9 times 9 times 9. So x plus 2 is going to equal 9, so x must be 7. We're not done yet, though. because now we have to figure out the volume of the smaller cube, which is 343. And 343, and then the volume of the larger cube will be 729 centimeters cubed. So if we want to figure out the total volume that will spill, we will have to subtract the large volume from the small volume. So 729 is the large one minus 343, and we'll have 386 centimeters cubed of water will spill. Okay, I hope this lesson was helpful, and we'll go over any questions in class.